Pierre de Fermat was born August 17, 1601 in Beaumont-de-Lomagne, France. He died January 12, 1665 in Castres, France, and he studied at the University of Orleans in France.
Fermat was born in a Catholic family as one of 4 children. His father was a prosperous leather merchant, and his mother was a parliamentary noblesse de la Robe. Fermat began his secondary schooling at the convent of Cordeliers. This was an institution run by Franciscans in France. This information was found on mathsforeurope.digibel.be/pierredefermat.html. Alright.
Pierre de Fermat acquired his degree of Bachelor of Civil Laws in 1631 from the University of Orleans in France. He never had any trouble with money as he was financially secure throughout his whole life. This financial security allowed him to purchase his way into Parliament for 43,500 livres. The date in his name originates from his position in Congress in which he bought his way into. He frequently communicated with many great mathematicians in Europe at the time, and this helped him discover his own last theorem, which became known as Fermat's last theorem. Now that we've given you some background about Fermat, we're going to talk about his contributions to math. The 3 main contributions we found are Fermat's theorem on the sums of 2 squares, Fermat's little theorem, and Fermat's last theorem. Fermat's theorem on sums of 2 squares states that any odd prime number will be the sum of 2 square numbers if and only if it leaves a remainder of 1 when divided by 4. For example, 17 divided by 4 is 4 remainder 1, so 17 would work. And the way to write that would be 1 squared plus 4 squared. This can also be written as z equals x squared plus y squared if z equals 1 mod 4. It basically means remainder 1 when divided by 4. Here are some example problems. Find the sum of 2 squares if the prime number is 29. The answer was 2 squared plus 5 squared. For another example problem, find the sum of 2 squares if the odd prime number is 269.
The answer you should have gotten there is 10 squared plus 13 squared. Now let's move on to Fermat's little theorem. We're moving on to Fermat's little theorem, and the equation says a to the power of p minus 1 equals 1 mod p.
Alright, Fermat's last theorem states a to the n plus b to the n does not equal c to the n for any n value that is less than 2. This simple theorem defeated the best mathematicians for over 350 years. Andrew Wiles finally provided a proof for this theorem that was a 108-page long document that only a handful of mathematicians in the world can fully comprehend because of its complexity.
Wait.